11.6 applications, it's MA 912, AR 1.2, 5.2, 5.4, and 5.7. MA.912.F.1.2 and MA 912 NSO 1.7. We're going to use exponential equations to solve compound interest problems, use exponential equations to solve growth and decay problems, and use logarithmic equations to solve intensity problems. So previously we talked about compound interest. Now there's two formulas for compound interest. The first one is n compounding per year, so we would know it as A equals P for principal times 1 plus the rate over the number of times raised to the nt power, and then continuous compounding, which is known as A equals P e to the rt power. So in example 1, it says finding the annual interest rate. An investment of $50,000 is made in a fund that compounds interest quarterly. After 4 years, the balance in the fund is $71,381.07. What is the annual interest rate for this fund? So it told you quarterly in this problem. Because of the quarterly piece, we are going to be using compounding per year. So the first thing we're going to do is we're going to write our formula. A equals P times 1 plus R over N raised to the NT power. So our investment amount is our P. So I know that P is 50,000. I know that it says that it's quarterly value. So our N value is 4. In 4 years, that's our time frame. It reached a balance of $71,381. So I know that that's our A value, $71,381.07. So now we're going to replace our pieces. So we have $71,381.07 equaling our starting amount, which is $50,000, times 1 plus our rate, and they told us our rate is what we're trying to find, which is our R value, so we're not about, it's going to stay R. The number of times it was compounded said quarterly, that means it's 4 times a year. The N is our 4, and the time frame was 4 years. So now we're going to divide both sides by 50,000. So we're taking our calculator, so 71,381.07 divided by 50 grand. Gives us 1.4276 equaling 1 plus R over N, which is our 4, raised to now 4 times 4 is our 16th power. So we're at this point. So now at this point, we need to raise both sides. I need to get rid of this piece, so we're taking the root of both sides. So we're taking the root of 16 to both sides, because I want to break the bond. So I can raise this to the 1/16th power. It's the inverse of this. So now I'm going to say our answer, and we're raising it to 1/16. Gives me 1.022. I'm going to go with a 5 equaling. This side gives us 1 plus R over 4. Then I'm going to subtract the 1 over. So I'm going to get 0.0225 equaling R over 4. And if we think of cross multiplying, R is equal to 0.0225 times 4 is 0.09. So 0.09 is our answer. Remember, rate is in percentage, so this is, think of multiplying by 100, so 9%. Example 2 is doubling time for continuous compounding. Says an investment is made in a trust fund at an annual interest rate of 8.75%, compounded continuously. How long will it take for the investment to double? So first thing, we're going to use the second equation we had for continuous compounding, which is A equals P e to the RT. And it said it wanted us to find when it doubles. So you got to think of it as 2P equaling PE. Now the percent is 8.7, so we know that our R is 8.75%, but as a decimal, it's 0.0875. So the 0.0875, and RT, because that's what we're trying to run, is our time frame. So on this instance, our p's are going to cancel each other out, leaving us 2 equaling e to the 0.0875t. Now, it's in base e. In order to get rid of bring down the exponent, remember, you're going to take the natural log of both sides. So we're going to say ln of 2 equals 0.0875 with a t. With the calculator, we're going to find the natural log of 2. So natural log of 2, that gives us 0.6931 equaling 0.0875. And then divide both sides by that point value. 0.0875. It says our time frame is 7.92. So it's going to take about 7.92 years for our investment to double. Example 3 is finding the type of compounding. So it says you deposit $1,000 in a fund. At the end of year 1, your balance is $1,077.63. The annual interest rate for the fund is 7.5%. How is interest compounded? So first thing, we tried our first basic formula, which is amount equals the principal ERTRT, to see if we result in the balance. So we get our principal was $1,000, e to the rate, which is 0.075 in 1 year. So with our calculator, we do 1,000, e raising it to the 0.075, and it gives us 1,077.88, which is in a year. That means that is not what they gave us. So now we're going to do the second formula, which is a equals p times 1 plus r over n to the nt power, and it's easiest to use a table for this value. So we know that our n is our formula, which is 1,000 times 1 plus the 0.075 over n that we don't know, raised to the n power, and we're going to do in 1 branching, in 4, in 12, and then 365 days, because we want to know which one we come up to be. So the value of n is 1. So if I plug in 1 in here, when n is 1, we get 1,000 times 1 plus 0.075 over 1 times to the power of 1. So we're just seeing 1,000 times 1.075. So 1,000 times 1.075. That gives us 1,075. So it's not a value of 1. Now we're going to try when it's being compounded quarterly. So we have 1,000 times 1 plus 0.075 over 4 to the 4th power, because that's the n again. We have 1,000 times 1 plus 75 divided by 4. It's 0.01875 to the 4th power. We have 1,000 times 1.01875 raised to the 4th power. So with the calculator, we're going to do 1,000 parentheses 1.01875, close it, and then raise it to the 4th power. We get 1,077.3014. So now we're going to try 12 times, which means it's being done monthly. So now we're going to do, again, we are going to raise the value of 12. So we have 1,000 times 1 plus 0.075 divided by 12 to the 12th power. We get 1,000 times 1 plus 0.075 split 12 ways, and 0.00625 to the 12th. So we get 1,000 times 1.00625 to the 12th power. So again, with a calculator, 1,000, parentheses, 1.00625, close it, raise it to the 12th power, and we get 1,077.63, which is what we started out is what we wanted to match. So we are actually being done monthly. Effective yield is the year's interest divided by the amount invested. So if we want to find the effective yield, it says an investment is made in an account that pays 6.75% interest compounded continuously. What is the effective yield for the investment? So first thing, I need to find out what was my amount at the end. So first thing we need to use A equals PE to the RT because that is the compounding continuously formula. They tell you we're investing an amount is what we want to find out. And then come up with the effective yield. So if we choose a value, we're going to choose a value. They didn't tell us a price here. So we're going to pick, we're going to say the P was $1,000, our investment. So we have $1,000, E to the rate, and it says compounded continuously. And they told you your rate is 6.75%, so it's 0.0675. And they want to know, and it says time frame, we're going to say 1 year. So we get 1,000 E to the 0.0675. So we get 1,000 second ln to 0.0675. And it says we yielded 1069.83. Okay, so now remember, it means we earned $69.83 over the $1,000. So effective yield is the year's interest. So our year's interest was $69.83. And then our amount that we started out with was our amount invested. We invested $1,000. So effective yield is our investment earnings over what we invested. So when we come out with this, 69.83, divide that by 1,000, it gives us 0.06983, which if I want in decimal format, is 6.983%. Exponential growth and decay says that the mathematical model for exponential growth or decay is given by y equals c e to the kt. So for this model, c is the original amount and y is the amount after time t. The number k is going to be a constant that is determined by the rate of growth or decay. So when k is greater than 0, the model represents exponential growth. And when k is less than 0, meaning it's negative, it represents exponential decay. In example 5, it says, a college created an algebra tutoring website in 2010. The number of hits per year at the website has grown exponentially. The website has 4,080 hits in 2010 and in 13,872 hits in 2015. It says, predict the number of hits in 2021. So, first thing we need to do is identify our equation. We know that it's going to be y equals c e to kt. And we know that it says in 2015, which is 5 years after the initial hit website. So remember, 2010 is initial. Think of that as year 0. 2015 is 5 years later. So we know that we're going to use the t time frame is going to be 5 years. So we don't know what our y is. That's what we're trying to find. But we know that it ended here. So we're going to say 13,872 equals the c that we don't know what we started out with. But we do because they gave it to you. It says 40,080 hits. So we're going to make that the 40,080 hits. K is what we don't know. We don't know our constant, but it said we did it in 5 years. So now we see we're going to divide both sides by 40,080. So So we're going to do 13,872, divide that by 4080. We get 3.4 equals e to the 5k now, because now we're doing exponentials. So there's a base e, so it means we need to take the natural log of both sides. So you're going to do ln of 3.4 equals 5k, and then divide both sides by 5. So we're going to say ln of 3.4, close the parentheses, divide your answer by 5, so we get 0.2446 is what we're going to go with. I rounded to 4 decimal places, so this is what our k constant is. Now it says, we know what k is now, but it says predict when it's going to hit 2021. So remember, 2021 minus 2010 means it's gone 11 years. 11 is our value for our time frame. Now we're going to take our original equation. We know we started out with 40,080, so that was our starting out. E raised to the k, we know what k is. It's 0.2447, actually 448. And then our time frame is now 11. So in the calculator, you're going to do 4080 times second ln, and in parentheses you're going to put 0.2448 times the 11, and then close the parentheses. So we come up with 60,273.76. And normally we're going to round to the nearest whole number, so 60,274. An example says it's about radioactive decay. It says radioactive iodine 125 is a byproduct of some types of nuclear reactors. Its half-life is 60 days. That is 60 days later, a given amount of the radioactive iodine 125 will have decayed to half the original amount. A nuclear accident occurs and releases 20 grams of radioactive iodine 125. How long will it take for the radioactive iodine to decay to 1 gram? So first thing, we need to start out with our formula for growth and decay, which is y equals ce to the kt. Now, remember, it started out originally time frame of 0, and they tell you that it starts out, we have the time frame of 60 days. They want the constant time frame is 0. So we're basically saying we released 20 grams. So if I do y equals 20 e to the k times 0, which is still 0, we get 20. So our c value right now is 20. That's what we start out with. Now we want to find out what happens to be a half-life. It says to get to a half-life situation. So it means half the value. So y is going to be the equivalent of 10. So we're taking our equation, y equals ce to the kt. We got to get to 10. We start out with 20. Our constant, we don't know, we're trying to find it. But it says that our time frame is 60 days. They told you 60 days, so I'm going to say 60k. So now, because we've got to find our k value. You're dividing by 20. So you get 0.5 equals e to the 60k. You're going to apply natural log, so you're going to ln of 0.5 equals 60k. So k is ln of 0.5 divided by 60. So with a calculator, you're going to do ln of 0.5 closed divided by 60, and we get negative 0.01155 is our k constant. So we know our k constant. Now it says they want to reach 1 gram. So that's what our value for y is. So again, we're going to go back to the original equation. So y equals CEKT. We need to reach 1 gram. We started out with 20. We know our k value. It's negative 0.01155. And then remember, that we need to find our time frame. We're trying to find t now. So we're dividing both sides by 20. So 1 divided by 20 is 0.05 equals e to the negative 0.01155t. Again, we have to apply natural log. So we have ln of 0.05 equals negative 0.01155t. If we do natural log of 0.05, we get negative 2.996 equaling negative 0.01155t. And we're going to divide both sides by that value. So in the calculator, I'm taking the value that's already there and I'm just hitting the divide bar, negative 0.01155, and I get time equals 259.37. So if we think about it here, we're going to go around to one decimal place. So it's 259.4 days. Intensity models. On the Richter scale, the magnitude R of an earthquake is given by the model R equals log base 10 of I, where I is the intensity of the shock wave. So in example 7 says, on January 14th, 2018, an earthquake near Acari, Peru measured 7.1 on the Richter scale. 15 days later, an earthquake in the same region measured 4.7 on the Richter scale. Compare the intensities of the two earthquakes. So first thing, we want to do the intensity of the earthquake in January 14th. So we're going to start out with January 14th. And we're going to write our formula. R is equal to log base 10 of I. And then they told us that it hit 7.1 on the Richter scale, so 7.1 equals log base 10 of I. So now, remember, log base 10 of I, you're applying you're raising both sides to the 10 power. You're basically saying 10 to the log base 10 of I equals 10 to the 7.1. The 10s are canceling out. This side is canceling out, leaving you the letter I, and you're just saying 10 to the 7.1 power. So 10 to the 7.1 gives me a value of 12589,254.12. That's the intensity value. Now we're going to find the intensity value of the following 15 days later. 15 days later puts it at January 29th. So again, R equals log base 10 of I. And then we see it was 4.7 equals log base 10 of I. So again, we become 10 to the 4.7 power equals the letter I because we raised both sides. So now, if I were to expand this out, 10 to the 4.7 gives me an intensity value of 50,118.7. So now, they want us to compare the intensities of the two things. So we're going to make a ratio. So it's going to be the intensity of the January 14th one, earthquake, over the intensity of the January 29th. But I'm going to use just the exponential forms. So in 14 we were 10 to the 7.1, and on the 29th we were 10 to the 4.7. So remember the rules of exponents. If the bases are the same and you're in fraction form, you are subtracting them. So it's basically saying 10 to the 7.1 minus 4.7. So we get 10 to the, okay, so 7.1 minus 4.7 results in 2.4. So now the ratio is saying 10 to the 2.4, which is giving me 251.2. If we want to do whole numbers, then we're going to go with 251. What it means is the earthquake on January 14th was 251 times greater than January 29th.